So we are back with 7.6 and more graphing, solve systems of linear inequalities. So we've already touched on inequalities in chapter 6. So now we're actually going to graph them. So a system of linear inequalities in two variables, meaning x and y normally, or simply a system of inequalities, consists of two or more linear inequalities in the same variable. So they have an example, x minus y is greater than 7. That's your first inequality. And 2x plus y is less than 8. So a solution is a system of linear inequalities is an ordered pair that is a solution of each inequality in the system. For example, 6, negative 5 is a solution of the system above. The graph of a system of linear inequalities is the graph of all solutions of the systems. So I will show you what that means. Right now, I'm sure you don't understand what they're talking about, but let's go ahead and start by graphing, and then it will start to make sense. So here's the two. Y is greater than negative x minus 2. You always want it in the form y equals mx plus b. Okay? It makes it easy to graph, and you're familiar with that. Then the other one is y is less than or equal to 3x plus 6. All right? So there's two things that are really important about inequalities, is if something is included or not, and we've already touched on that early in chapter 6. So when you have the equal sign, that's a closed circle and it includes that number. So in this that we're graphing, that would equate to a solid line. So I'm going to show it by the red line. If I have something, and it doesn't matter which way it's going, it could be going greater than, less to, if it has that equal, this is the equal, it's a solid line. So in math, you have to find shortcuts because you don't have vocab in the sense that you're writing words. You have to be able to look at things as a mathematician or somebody who's looking at math and understand what it's saying immediately when you look at it. So we have to rewrite something that's not included, whether it's less than or greater than. Remember, we had the open circle in chapter 6. But now that line, how do we show that on the line? It can't be solid, so we show it by dotted or dashes, they call it. Dashes or dots, whatever you want to. I think dashes is what they call it. So I'm going to use two different colors. I'm going to use green for one and blue for the other. So let's go ahead and do this one. So it's already in slope-intercept form, so that means on this one I start at -2. So right here. And then my slope is -1, so that's understood to be the, so go down 1 and over 1. And I'm going to do this a few times. It's real easy to do. I can go here, a positive by a negative will give me that too, so you can see that the line is going up that way. Here I'm trying to find my ruler so I don't mess it up. Give me a second. Okay, here it is. So this is my ruler. So now this is what I have to be careful of. I'm doing the first one, so a lot of times what I'll do is I'll do this to begin so I don't forget. It is a dashed line. So when I do it, I have to be careful to show it as dashed. That means all the numbers on this line are not included. Okay? So that's the first really important thing. The second thing is that we're going to have solutions, so we have to test and see if this part of the line is where all the solutions are, or the top part is, because it's separated by dashed line. So we know numbers on the dashed line are not included. So 99% of the time, the number that you can test, because you got to test, okay, a number, you test a number either on this side or clearly on this side. But I like to test 0, 0 because it's easy to plug in 0, 0 for x and y. So look, 0, 0 would be on the top. So if I test this number and it makes this inequality true, then that means all these numbers right here are part of the solution. If you have 0, 0, then you have to have everything above the number line. So you would graph that part. So we're going to go back and we're going to test 0, 0. So 0 is greater than negative 0 is just 0. 0 minus 2. So I am plugging a 0 in for here, and then negative 0, I'm plugging it in for x, it's just 0, and 0 minus 2 is negative 2. So is 0 greater than negative 2? Well, hopefully you tell me yes. So I'm just very lightly gonna put some things here showing that the top, all these solutions are true. So if I went ahead and I said 1, 0, 5, 4, all of these, if I tested them for x and y, it would always be true. So all the solutions at the top, if one point at the top is true, all of them are true. If one point here is false, then all the ones at the bottom are true. Do you understand? So it's understanding what you're doing, and it makes sense. So now we have to draw the other line, because what we're looking for is an intersection of these two lines where all the solutions are true for both of the lines. So let's go ahead and draw this. Maybe we draw this one in a blue. Okay, so y is less than or equal to means that now I have a solid line. So I start at 6, 1, 2, 3, 4, 5, 6, that's my y-intercept, and then positive 3. So up 1, 2, 3 and over 1. But then I want to go down this way. So remember, to get a positive, a negative divided by a negative is a positive. So I can go 1, 2, negative 3 down and over negative 1. Same thing here, negative 3. No. So here I'm going to make the line solid because it is solid. Now I'm going to test 0, 0 right here, because I don't fall. It doesn't fall on the line. The only time you can't test 0, 0, 99% of the time you can use it, but you can't use it if the line itself is on 0, 0, and that happens once in a blue moon. But if it does, you pick another point that's well out. But I like 0, 0 because it's easier to remember it for x and y. You don't have to think about it. So let's go back to the second inequality. So 0 is less than or equal to 3 times 0 is 0, 0 plus 6 is 6. So is 6 greater than 0? Yes, it is. It's not equal to, but it's greater. So that means now I can go much darker. That means this is included. So all of this is included where they overlap, and all the way up to the dash line, but this part of the line is not included. Do you see that? Because it's dashed. This is solid, so you shade. Sometimes it helps to have like two different colors, or very light on one color, a light yellow or light, and then where they overlap you make it real dark. So that means if I picked any number here, 5, 4, it would be true for the first and it would be true for the second. So that's what they're trying to show you by looking at that graph. Okay, so let's go ahead and do one more. Okay, graph a system of 3 linear. Ooh, we're going to do 3. All right, so let me go ahead and move down like this. Okay, so we don't confuse, and I've got plenty of room to write. So y is greater than or equal to negative 1. X is greater than negative 2. And x plus 2y, I like this, is less than or equal to 4. Because these two are done, but this one's not solved for slope-intercept. So let's go ahead and solve it. So subtract x, and sometimes they're not. So 2y is less than or equal to negative x plus 4. And remember, when you solve an inequality, if you're ever dividing or multiplying by a negative, you flip it, but you're not here. So y is less than or equal to negative 1/2 x plus 2. So I'm looking at this one, and this one. I just wanted to circle them so that you can see. So let's start with the easiest ones first. Y is equal to or greater than negative 1. So hopefully you remember that that's just a horizontal line, but it is a solid line. So you go down to negative 1, and here's my line. Put your arrowheads on. So think about it. Is it great? It's greater than -1. So 0, 1, 2, 3. So just real light, because remember we're overlapping 3 lines. So I know it's above it. Then I'm going to go to the other one. X is greater than -2, but it does not include -2. It's got a dash line. Okay, so these two equations have solid lines, but this one is a dash line. So now you go to -2 and you put a dash line here. So I'm doing different colors. And x is greater than -2, so if it's larger than -2, it'd be 0, 1 stuff. So we can quite clearly say it's here, but I can't go past this green line, okay? So I'm already stopped by the first line. So this is where these two are overlapping. Now, for fun, we're adding a third one right here. Y is less than or equal to -1/2 x plus 2. So it's in slope-intercept form, so let me pick, okay, I've got red and green, Christmas colors. Let's go ahead and do blue. So we're going to go to plus 2 right here. That's a y-intercept, and the slope is down 1 and over 2, down 1 and over 2. Again, this is a solid line. So I'm going to go ahead and say psht. Okay, so again, I'm going to test 0, 0 here, because on this one I have to test. So we're not crossing the origin. So right here is where I'm testing. So go back into 0 is less than -1/2 times 0 is 0. 0 plus 2 is 2. Is 2 greater than 0? Yes. That means that the part where they all intersect is right here. So you would take this. Now the red line, the dash don't count, and that's your boundary. That's where any number that I pick in here will be a solution to this one, and this one. Anything out here, here, underneath is not. Okay? So it's, you're looking for an overlapping region where they both make solutions. Okay? So I'm going to let you read one. So I'm going to use the one because I've got it all nicely. So let's like hone in and look at it here if we can see. So let me autofocus this a little bit better. Okay. So we're going to see a system where we have 2 lines and we have to write a system. See, that looks a lot better. So write a system of inequalities for the shaded region. So this is a shaded region. So I can look and I can see one dash line is coming here and one solid line is going there. Alright, this is the origin right here at 0, 0, so that has nothing to do. So there's 2. So the first one I'm going to look at is this. This is a solid line. And this is y is greater or equal to 3. And the reason it's greater because it's going above 4, 5, 6. Okay? So that one's real easy to write. So that's the first part of the solution. Then the other one is this dash line. Okay? So it crosses through 1 right here. And then I find the slope is up 1, 2, and over 1 gives me another point. So the slope is 2. Alright? So then I know it's not equal to, and again, it's greater, it's above the line. If it were under the line, it would be less than. So if it was under this line that we were shaded, it would be less than. But if you're not sure, plug some points in and then you'll know straight away if it's greater than. So y is greater than 2x plus 1. So, and it tells you here, because the shaded region is above the dashed line. So you can see it's above it, okay? So hopefully you can see that. It's fairly simple to look at one and be able to write an equation. So you might have that where they give you 2 lines and then you have to write the actual inequalities for both. Okay. So let's look at this one. It does not have the answers. So look here. This is a fairly straightforward one. Here is the origin. So if I were going to write an inequality here, the first one I can see is I've got a dashed vertical line going through 2. So x is less than 2 because I've got 1, 0, and that would be the first inequality, the system from here. The other one is this one. This is a y equals, so 0, 0, 0 is 1, 2, 3, 4. So again, is it going above the line or below it? It's going below it, so y is less than 4. So those would be the two systems of inequalities, or the system of inequalities. These would be the two inequality equations, this one and this one, that would make this true. So let's look at this. Okay, so I know that this is 0, 0, so it's the origin, so don't confuse that. I've got a dashed line here, and then I've got a vertical line here. So obviously the vertical line's the easiest one to do. So this is going by 2's. Okay, I realize that the origin is right here. So sorry. I thought the origin was here. Here is 0, 0, because that's 1, 2, 3. Alright, so that means I have a vertical line. Sometimes you have to be careful. You can see how easy I just assumed, but it was right here. So 1, 2, 3. This is a vertical line. And x is less than 3. So that's the first one. Would be right here. Then I have this dashed line right here. So for right now, I'm going to say y. I know the y-intercept is at -1, 0, -1 is right here. That's that part. And then the slope, I'm going to use this point, maybe use this point to count the slope at 1, 2, up 2, and then 1, 2, 3. So it's 2/3. Now, is it above the line or below the line? If it's above the line, y is greater than 2/3 x minus 1. So hopefully you understood what I did. You have to find the origin first and then look at the line. So we know that's the y-intercept's at -1. And then the slope is up 2 and over 3. And then I know it's a dashed line, so it's not going to be equal to. So let me write this a little bit spread out here, because I kind of read it backwards. So this is above is shaded, so y is greater than 2/3, because y are all the solutions, they're above the line. And then here, this is this other line here. By the way, this is a solid line, so thank goodness I look back at this. This is less than or equal to, because I can see it's a solid line now, and this is a dashed line. So this would be correct. Good thing I looked back at that. So x is less than or equal to 3, this line, and then y is greater than 2/3 x minus 1. So hopefully you practice, and hopefully you like graphing and shading, because that's what you're going to be doing a lot for. So I think this is the last section in chapter 7, so we'll be going on and getting ready for a test. Love you guys. God bless.